Question 10, last one of the pack, and a fiendish little one to finish off. This question is about the preparation, properties and uses of lactic acid. We've got the structure there. When heated strongly, lactic acid forms a cyclic diester. The diester has a molecular form of C6H8O4. Draw the structure of the cyclic diester. So look at the name first of all. Look at what clues the name gives you. Cyclic, so you're thinking about the molecule is making a circular structure. Cyclic doesn't necessarily mean benzene, but you've definitely got a circular structure within your whole molecule. Diester means there's got to be two ester bonds. Di is two, so there's got to be two ester bonds in the molecule. And look at the molecular formula. That is clearly double the molecular formula of one molecule of lactic acid. Okay, so this diester is basically forming out of two lactic acid molecules. Now think about it. An ester is formed from the reaction between carboxylic acid and an alcohol. So it's feasible, therefore, that when the lactic acid can, in essence, react with itself to produce an ester with itself. Okay, it's possible for an ester form between the OH group here and the OH group there, and you get an internal ester forming here, which is called a dimer. But what you can also get then is with two lactic acid molecules, the COOH of one molecule will react, well, the OH group here on the COOH will react with the OH group of the alcohol group of another lactic acid, and vice versa. So we get the ester forming at both ends of the molecule, and that is what is happening here. Now this is a tricky one to try and draw, try and visualize, all right, because you've got to link the two molecules together, all right. So what I'm going to try and do is draw out two lactic acid molecules. So we've got the first one. I'll draw it in the same form as we can see here. Oh, beg your pardon, I'll put a random H in the middle. Let's get rid of that. C, H, here's my OH. I'll draw it all in full display so we can see everything we've got. O, O, and H. So there's my one lactic acid. If I draw a second one and try and reverse it, if I put the C, O, OH there, C, OH there, H, and then the CH3. So what I've just done is it's just a mirror image of this one. Now you can start to see what I'm talking about. So esters form between an alcohol and a carboxylic acid. So what I can do is remove the water here and form an ester link between the OH group of this lactic acid of the alcohol bit and the OH group of the carboxyl group on the second lactic acid molecule. So I can get an ester bond forming here. And then likewise here, I can remove water there and get a second ester link forming there. And that's essentially what you're trying to draw. You're trying to draw the ester, the bond that's forming between the molecules there and there. So we try and draw this out. All right, it makes sense to try and draw that as a hexagon, but you haven't got to, as long as you show the ester bonds forming between these two things. So we could do, we could have it looking like this. So C, C, double bond O, O, and then I've got the H and the CH3. So this bit here is there. Okay, they're not involved in the ester. Then I've got this O here bonding on to this C there. Then I've got my other double bond O there. And then I've got the next carbon here. That's got the hydrogen and the CH3. And then you've got the link then between this carbon and the oxygen here, which is there. There is your cyclic diester. This type of question has cropped up a few times in the last few years. The examiners have spotted that this is an area that students struggle with, so it's well worth having a look at this one, in a detail, and really picturing what's going on with that molecule.